Hi, so this is our project presentation for computer organization and architecture. So for our team members, we have Muhammad Adam Harid bin Hashim, we have Muhammad Afiq Shahir bin Abdul Rahim, we have me, which is Muhammad Abdul Rashid bin Murad, and also we have Pravin, anak lelaki Lek Cumanan. So for the introduction, modern program utilize a various demand on CPU resources. However, performance can vary significantly depending on the microarchitectural features, memory configuration, and also storage subsystem. The CPU benchmark will provide the standardized assessment for user to compare the best processor to the best match for their needs. This project aims to analyze and compare CPU performance of the three laptops using the free software tools and writing and assembly code program for benchmarking. So for the objective is first we gather the required specification on each laptop using the benchmarking tools such as CPU ZAC, Geekbench, Window Task Manager, and also Mini Tools Partition Wizard. Other than that, we also implement and record the polynomial computation in assembly language to execute multiple loop count. And lastly, based on the result that we got, we will determine the effect of the core speed, cache size, memory bandwidth, and also the I/O performance on the benchmark result.
Hi, Assalamualaikum. My name is Adam Harid. I will present benchmarking, execution, and result. So for the first one, we collecting specification of your computer using CPU ZAC. So the objective is compare specification across three top models, and we use tools CPU ZAC, and our focus is monitoring real-time clock speeds or voltage and specification. So this is the result for the MSI 1015, and then this is the result for the Asus VivoBook 16. Um, and then here for the lastly for the Acer Nitro AN515-58. So this is the analysis, comparison, and discussion for the core speed. Based on these three laptops, the MSI 1015 has faster core speed than the others. A greater core speed indicates that the CPU can handle more instructions per second. Based on the result, each core of the MSI 1015 can execute up to 3.092 billion cycles per second. So this is the second for the cache. As you can see, Asus VivoBook 16 and Acer Nitro has larger L1 and L2 cache than the MSI 1015. Acer Nitro leads with an 18 MB L3 cache, which is ideal for heavy multi-thread workload. The next one is for the memory. MSI 1015 have a 24 gig DDR4 memory, ideal for heavy multitasking and video editing. For the Asus VivoBook 16, we have 16 gig DDR4 single slot, so it's more ideal for plenty for productivity but limited upgrade parts. So for the Acer Nitro, we have 8 gig DDR4 to slot, suit to everyday tasks and upgradable up to 64 gig for increased bandwidth. So this is for the motherboard. MSI 50, MSI 1015 have a single fan with heat pipe optimized for budget gaming and ample upgrade parts for RAM and storage. So for the Asus VivoBook 16, um, it's compact heat pipe, single heat pipe design with one fan, and then its slim build limits RAM and storage expansion. So lastly for the Acer Nitro, it's used ADL Gemini ADH dual fans and multiple heat pipe for sustained performance, strong support for future RAM and SSD upgrade. Next, for the CPU test with variation of method using Geekbench. So our objective is a compare CPU test result across three laptop models. So the tool we use is Geekbench, and our focus is the score of the single core or multi-core performance. So this is the result for the MSI 1015. The single score. This is the single core score, and the multi-core score. And then this for the Asus VivoBook 16 result. And the last one, this is the result for the Acer Nitro. So based on the system information, the table compare MSI 1015, Asus VivoBook 16, and Acer Nitro. The MSI 1015 is an affordable gaming laptop with an Intel Core i5 processor and NVIDIA RTX graphic, suitable for casual gaming or multitasking. The VivoBook 16 is lightweight but lacks integrated graphic for demanding tasks. The Acer Nitro is more suitable for gaming and multitasking. So this is comparison for the single core and the multiple core score. So Geekbench single core and multiple core score section show that the Asus VivoBook 16 and Acer Nitro have higher score for single core tasks like web browsing and word processing. The MSI 1015 with an Intel Core i5 12450H leads in multi-core performance with a score of 6442, followed by the Acer Nitro and Asus VivoBook 16. This higher score is beneficial for users primarily using single-thread software. So the next one is invoke different process and application as categorized as low, middle, and high load. So our objective is compare memory usage result across the three laptop models. The tools we use is a task manager, and our focus is show the memory consumption can be released and looking at the monitor performance. So this is the result for the MSI 1015, low load, middle load, and high load. And the next is for Asus VivoBook 16, and then the Acer Nitro. So, based on analysis and comparison discussion, um, for the low load, less than 59%, all three laptops show comparable memory usage, indicating efficient baseline system performance. So, based on the medium load, VivoBook 16 steady memory grow 74% with moderate CPU use is 70%, suggests reliance on RAM multitasking. MSI 1015 and Nitro sharp memory spike 82 until to 85%, possibly from background operation and game preloading. So for the high load, greater than 91%, 1015 high CPU utilization 71% reflect resource strain and potential inefficiencies in process handling. VivoBook 16 high memory usage 94% but moderate CPU effort 48%, pointing to limited memory bandwidth or soldered RAM constraints. So for the as a Nitro, minimum CPU usage despite heavy load suggests effect catching and superior terminal design. So next for the CPU, so for the low load, all laptops exhibit a minimal CPU usage, 1% until 15%, reflecting efficient baseline power management. So for the medium load, MSI 1015 use a usage spiked to 58%, suggesting active handling of increasing background and foreground processes. So for the VivoBook 16, growth moderate to 70%, showing memory depend task execution due to soldered RAM limiting bandwidth. So for the Acer Nitro remain low at 3%, pointing to strong base clock and terminal headroom ideal for multitasking. So for the high load, Tin 15 peaked at 71%, stressing CPU core likely bottlenecking from accumulating tasks. For the VivoBook 16 reached 48%, revealing CPU moderate but aggressive RAM utilization instead. So for the Acer Nitro, hold impressive low at just 7%, indicating high efficient and optimized thermal regulation.
So hello everyone, today I'll be presenting the storage performance analysis that we conducted using Minitool partition wizard to test and compare how three different laptops handle storage size using various data block size. So the objective of the project was to read and write speeds of three laptop models, which are the MSI Thin 15B12 UCX, the Asus VivoBook 16, and the Acer Nitro AN 5.558. So Miniature Partition Wizard is a benchmarking tool that evaluates sequential and random storage performance. So our focus was to see the transfer sizes ranging from 4 kilobyte to 32 kilobyte, which reflect typical real-world computing tasks from launching apps to video editing. So these are the results we obtained using three different laptops using Minitool Partition Wizard. So we compute this in a table form and we use four performance metrics, which are the sequential read, sequential write, random read, random write, which are the which used for measure how fast the system can read large continuous blocks of data or continuous data or small and scattered read operation or background processes and catching. So for sequential read, we can see that Acer Nitro outperformed across all block sizes. At 4 kilobytes, it achieved 1041 megabytes, significantly ahead of MSI at 736 megabytes and Asus at 176 megabytes per second. So as block sizes increase, we can see that Acer performance continued to climb, peaking at 2240 megabytes per second at 32 kilobytes. This makes Acer ideal for media editing or backup scenarios. Meanwhile, MSI showed steady growth and Asus continued to lag across all sizes. So for sequential write, Acer again demonstrated the strongest performance where at 4 kilobyte it managed to get 962 megabytes per second and at by 32 kilobyte it reached 3740 megabytes per second, which is perfect for video saving and large file transfer. Asus on the other hand improved significantly as block sizes increases, peaking at 1388 megabytes per second, showing it performs better in large tasks. MSI, however, dipped sharply at 32 kilobyte with only 159 megabytes per second, indicating it's not ideal for large sequential writes. Randomly measured responsiveness and especially in multitasking environment. So at 4 kilobyte, Acer led again with 1045 megabytes per second, while MSI was fair at 573 megabytes per second, and Acer trailed at 423 megabytes per second. MSI performed best at 8 kilobyte with 766 megabytes per second, showing it optimized for scattered file access. At 32 kilobyte, all three showed their best result, with MSI and Acer both hitting over 1450 megabytes per second and Asus reaching 976 megabytes per second. So for random write, which is essential for background and catch data tasks, Asus stayed on top, starting with 964 megabytes per second at 4 kilobyte and soaring to 3784 megabytes per second at 32 kilobyte. Asus showed major improvement at larger sizes, reaching 1270 megabytes at 32 kilobyte, a strong finish. while MSI consistent but didn't improve over time, maintaining around 700 megabytes per second. So in conclusion, we can say that Acer Nitro clearly delivered the best all-round performance, especially at higher data tasks, which is perfect for power users, while MSI had the most consistent performance all across metrics, which is ideal for multitaskers and everyday users, while Acer struggled with smaller data operation but improved significantly with larger transfers. So we can say that it is a decent option for casual or budget users. Thank you for listening.
So this is for part two, where we want to do a benchmark using our ASM programming code. So once we run our code, so this is a five output example of our program. So at the top left is an output where the user input a loop n of 50, and at the top right is 100, bottom left is 200, bottom right is 500, and the bottom is 1000. So this is a table of all our output from that we get from our programming. So from the data that we can see in the table, we can make conclusions that as the number of loop increases, the execution time will also increase. So therefore, the execution time scales linearly with the number of loop. And next, when we look at the data, there is no spiking, and the data is very smooth. So we can say that the CPU is run the program very smoothly. Next, there is a small inconsistencies that we cannot avoid it, since it is caused by the multitasking nature of the operating system. And lastly is higher coefficient uh, means higher process uh, demands. So this means if the coefficient is higher, then the process demands will also be higher. So let's say the coefficient is high, so the process will be very slow.
So for the conclusion and reflection, in conclusion, the project successfully compare and analyze the CPU performance across three laptops using the free benchmarking program. So using this method, we identify variation in processor speed, cache size, memory type, and also the storage performance across each laptop. So the conclusion that we get is MSI Tin 15 excel at data intensive workload with which it 24 gigabyte RAM and the highest sustained core speed. For the SS VivoBook 16, it is ideal for everyday productivity thanks to its power efficient CPU and long battery life. And lastly, for the Acer Nitro AN 51558, it shines in gaming and also GPU bound tasks with its RTX GPU and the larger shared L3 cage. As for the assembly test, confirm the execution time grow proportionally with the loop count, enforcing the link between the instruction volume and the performance. Overall, this program taught us how to evaluate the hardware performance, interpret the benchmarking result, and graph the implication of various laptop specifications. This experience makes us more aware of the need of selecting the appropriate hardware depending on the specification we require. As a result, we gain a greater understanding of computer organization and architecture. That's all from me. Thank you. Hi, Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Rashid. So, for my reflection, during this whole project, I learned how to do benchmarking and also know how the specification of laptop can affect the performance. So for example, like the memory, the clock speed, and also how the CPU. So basically, this specification can affect the overall performance of the laptop. For example, like the clock speed. whether the single core, if the single core is higher, that means that the laptop can handle a heavy task, while the multiple core, if it is higher, then it means that it can handle multiple tasks in one time. For the memory, that means that it can handle multiple tasks also. So by doing this analyze and compare the benchmark of each laptop, I come to realize that for my needs during this whole studies, I can find that specification that suitable to my needs or my requirement. So other than that, during the analyze and the comparison, I also enhance my ability to make a comparison and analytic skill. So basically, during this whole project, I improve my skill and also I learn the system design of a laptop can affect the performance of the laptop. Thank you.
Assalamualaikum. My name is Muhammad Nohar bin Hashim. Here are my reflection. Honestly, this project was a huge eye opener. We got to really dig into how computers work, not just in theory, but actually messing around with three different laptops. Using tools like Porject and Geekbench, we saw firsthand how things like processor speed, memory, even storage really make a difference. It's totally uh, show us how even a small change in a program can affect how hard the CPU has to work. Uh, so lastly, it was a super practical way to learn about the computer hardware, and now we feel we're more confident about picking out the right laptop for whatever we need to do.
Working on this project has been valuable and eye-opening experience for me, as it provided me a deep insight about the real-world concepts of what we learn in computer organization and architecture course, and also helped me to understand how various hardware specifications affect the system performance. Other than that, the project strengthened my technical skills in benchmarking, broadened my understanding in hardware level performance, and prepared me to make more informed decisions when evaluating computer systems in the future. It also gave me greater appreciation for the importance of selecting appropriate hardware based on our user needs, whether for gaming, productivity, or intense multitasking.